All right. So um, two population means. Okay. And uh, kalau recall balik what we have learned last week, ianya adalah interval estimation, but this one is for one population means. This time it is for two population means. Okay, so insyaAllah kita akan cover yang ni lah by today. Okay, alright. So now I will share with you. Wait, yeah, I will share. Okay, alright. Boleh nampak my screen now? My module
Boleh doktor.
screen.
Boleh doktor.
Right, thank you. Okay, now this one, yeah, 2.4 interval estimation of two population means. So now let's recap what we have learned last week. So last week is interval estimation of one. Okay, one population mean. And when estimating interval for one population, what we do is we found we find the confidence interval for one population only. Okay, so for example, if the variance is known, we use this formula: x bar plus minus z alpha over 2 standard deviation of the population over square root of n. So what you will get is you will get say a and B, where A is the lower boundary and B is the upper boundary. And the lower and upper boundary or the range of this interval is for one population mean. It means that it is for the mean only. But now when it comes to two population means, we we would like to estimate the difference in the mean of the two population. Okay, so now let's say we have two populations, okay, and the two populations here must be mutually exclusive. For example, if we have gender, we have two population. One is a male population and the other one is female population. These are two mutually exclusive groups or populations. There is no overlap. Okay, there is no overlapping of one population to the other. Okay, we don't have like overlapping like this. No, no overlapping. Okay, no overlapping. So when wait, okay, so when uh getting or estimating the interval for two population, we actually want to find the difference in the mean of the two population. For example, we will have mean for population number one, okay, and mean for population number two. So what we want to find now is the difference between the two population. That is why the confidence interval is given by confidence interval for mean number one minus mean number two is equal to x bar 1, which is the average score for group number one, the sample average score for group number one, minus the average score for sample group number two. So from here, we know that this is the difference. Let's say x bar 1 is the male CGPA, male student CGPA, and x bar 2 is the female CGPA. So subtracting x1 minus x bar 2, x bar 1, and x bar 2, we will get the difference of CGPA between the two populations, right? And it is still the same. If the population is known, we will use Z alpha over 2. But if the standard deviation known, use Z. And if the standard deviation of the populations are unknown, then we use T. Okay, I will just write it first. Okay, so this is the formula. Okay, this is the formula. Okay, so you can expand this. Okay, this term is actually the standard deviation. You can also replace this with uh, over n1 and the variance for group number 2 over n2. Okay, the same as what I write here. All right, and for this one, for two population means there are three cases. There are three cases, and let me share with you case. Okay, so this is case number one, yeah. This is case number one. Oops, nope. Case number one. And for case number two, okay, case number one is used when the variances of the two variances of the two population are known. Sama macam yang one population mean. Cuma sekarang kita ada one and two. One and two. Okay, and for case number two, it is when the variances of the two population are unknown but same. Okay, means that uh, the variance score for population number one and the variance score for the population number two is about the same. Not much difference, or there is the variances are statistically equal. Okay, statistically equal or no difference. Okay, that is case number two. And case number three, okay, case number three is when the variances of the two populations are also unknown, but this time the variances are statistically different. Different variances for the 1 and 2, the two populations. Okay, so for case number 2, now let's go through the confidence interval first, the formula. For case number 2, the formula is given by confidence interval of the difference. Okay, this is the difference. Confidence interval of the difference is given by x bar 1 minus x bar 2, same as the first one here, but now the variances are unknown. Variances of the population are unknown. Okay, so when unknown, we will use T alpha over 2 degree of freedom. Okay, and for the case where the variances are same, okay, variances of the two population are the same, you have to find the pool standard deviation over, okay, pool standard deviation times 1 over n1 plus 1 over n2. So this is the formula for the case number 2. For case number 2, okay. So where the pool standard deviation can be found by calculating or using this formula, n1 minus 1 variance of population number 1 sample for population sample size for population number 2 minus 1 variance of the sample for population number 2 n1 plus n2 minus 2. And the degree of freedom here, how to get the degree of freedom here? It is n1 plus n2 minus 2. Because now we are dealing with two populations. Previously, for one population, wait here, one population, the variance, how to get the variance? N1 minus 1, right? 1, 2. This one. This is the degree of freedom, n minus 1. This is because we only have one population, okay? But now we have two populations, then the degree of freedom is n1 plus n2 minus 2. Okay, and for case number 3, okay, case number 3, it is the same confidence interval of the difference between the two population, okay, is equal to x bar 1 minus x bar 2 plus minus same unknown. Remember unknown, we use t, degree of freedom, okay, and for this one we will use variance over n1 plus variance for the sample number 2 over n2. Okay, dia nak sama macam yang nombor 1, the for case number 1. But now here we use T, and here instead of sigma we use the S, because we do not know the standard deviation of the population. So we will use the standard deviation of the sample lah here. So this is where it differs from the first one, from the first case. Itu adalah benda yang berbeza. Okay, but for this one, you have to find the degree of freedom by using this formula. Yeah. So the degree of freedom for case number 3 is not. It is not n1 plus n2 minus 2. No, it is the degree of freedom is given by s1 square over n1 plus s2 square over n2 square, okay, over okay, s1 square over n1 square over n1 minus 1 plus s2 square over n2 square over n2 minus 1. This is the formula that you need to use to find the degree of freedom for case number 3. Do not use this one. No, yeah? No. And don't worry, all the formula here will be given. It is in the formula tab, list of formula that I've shared with you. You don't have to memorize the formula, but it is better if you can memorize the formula. And usually all the informations required to calculate the pool standard deviation here, or the degree of freedom here, or anything or any information that is required to calculate the confidence here, it will be given. Okay, so don't worry about that. You just have to make sure that you insert or replace the right value into the formula. Okay. Any question so far? Do you have any question? No? May I proceed?
California
Sorry?
Tak ada soalan
Sorry?
Doktor.
Tak ada? Okay, alright. Thank you. Okay, now let's look at example 14. Okay, I think I need to. Okay, example 14. A survey of low and middle income households show that consumers aged 65 years and older had an average credit card debt of RM 10,235, and consumers in the 50 to 64-year group had an average credit card debt of Ringgit Malaysia 9342 at the time of survey. So from here, you already know that there are two populations, and these two populations are again, they are mutually exclusive. The first group is okay, household age 65 years old, okay, and older. And the other group is age 50 to 64 years old. We have two groups. Okay, so the average credit card debt for the first group is uh, RM 10,235, and for the group number two is RM 9,342. Okay, suppose that these averages were based on the random sample of, okay, so sample of first one is 1,200 samples, and sample for group number two is 1,400. Okay, so 1,200 and 1,400. Further, assume that the population standard deviation. Now, this is the keyword, population standard deviations. So from here, uh, remember, we have three cases. Case number one is when variances of the population is known. Case number two, unknown. And case number three also, case number three, also unknown, right? So by having this information, the population standard deviation is given, population standard deviations, we know that this is case for, we need to use the first case, okay? Case where the population standard deviations are known. So first one, standard deviation, yeah, 2,800, and number two is 2,500. Okay, let mu1 and mu2 be the respective population means for the two groups, people ages 65 years and older and people in the 50 to 64 year age group. Construct a 95% confidence interval for mu1 minus mu2 based on the interval are the mu1 and mu2 equal. Are the mu1 and mu2 equal? Okay, all right. So now we have all the informations required to calculate the confidence interval of the difference. Okay, now construct a 95% confidence interval. So what you have to do is it is actually the same like the one population. So 95% confidence interval means that we have how to get the alpha. Alpha is equal to 1 minus 0.95. So this is equal to 0.05. and alpha over 2 is equal to 0.025. Therefore, uh, we need to use the first case, okay? First case, variances of the populations are known, then use Z, right? Use Z, so Z 0.025 is equal to check the
1.96.
1.96. Thank you. All right. So you already have all the info. Oops. Wait. Yeah. Okay. So we can now calculate the confidence interval for the difference. Okay, by using this formula S bar 1 minus S bar 2 plus minus Z alpha over 2 square over N1 plus variance for position number 2 over N2. And what is the value again? S bar 1 is S bar 1.
10235.
Oops, okay. 10235 tolak
9342
9342 plus minus 1.96.
square
And this one
2800 square
2800 square. This one, please be very, very careful because the given information up here,
standard
oops,
deviation.
okay, is the standard deviation. But in the formula, we need to use the variance. Okay, so be careful. Over 1,200
And 200
plus
to 2500 square
yeah
over
over
1400.
400. Okay, so now you can solve the equation and find the lower and upper boundary.
687.46.
687. Oh, I remember one more thing is you have to include the because this is the final answer, and so remember to include the unit
Unit
687
0.46.
for 6, and for the upper boundary
1098
1098.54.
point 54.
Okay, so because our answer is in ringgit, so you can round up to two decimal places only. Don't have to use four decimal places lah. Okay. Saya rasa one okay 1098. So from here, okay, before we answer the second question is based on the interval are the mu1 and mu2 equal. Before that, I suggest you to write down the interpretation first. So from here, what we can interpret is we are 95% confident that the mean difference of what? Of what? Ambil daripada soalan of that. Okay, the mean difference of household debt. Household debt between the two populations is between ni tak payahlah that of the two populations is between RM 687.46 and RM 1098.54. Okay, so the way we interpret is a bit different compared to the one population mean, because now we um, we highlight the mean difference instead of mean only. Okay, for one population, kita buat mean je. We are 95% confident that the mean of apa-apa. But now, you need to add difference, mean difference, because here, the value that we calculated here is sebenarnya is actually the difference between the two population. Okay? Any question?
Tak ada, Doktor.
No, tak ada eh? Okay, alright. Now, saya nak kena padam. Saya nak kena padam all these. Ada cara lagi cepat sebenarnya kan? Saya rasa boleh highlight. Tak apa. Okay. Alright. Okay. Now, to answer the second question, we have second question here. Based on the interval, are mu1 and mu2 equal? Okay. So based on what you have calculated here, this is lower boundary, this is upper boundary. Can we say that the mean of the two populations are equal? Anyone?
No, sebab dalam range tu tak ada value 0.
Betul. So there are three possibilities bila you calculate the confidence interval. The first one is you may get negative for the lower boundary and also negative for the upper boundary. Second one is you may get negative for the lower boundary, positive for the upper boundary, or third one is both are positive. Okay. So nak tahu equal ke tak dua groups tu, dia mestilah in between the lower and upper boundary mestilah include 0. What does it mean? Bila include 0, it means that there is a possibility that the range ataupun the difference of the two population are the same. Maksudnya, contohlah kan, male CGPA minus female CGPA, you will get 0. 0, that means that there is no difference. 3.8 minus 3.8, for example. So it means that the mean CGPA of male is 3.8, mean CGPA of female is 3.8. So there is no difference, 0 difference. In between, ada kosong. So if like this one, this example, we get lower boundary positive, upper boundary is also positive, right? So for the lower boundary, we get 687.46. Upper boundary, we get 1098.54. In this case, 0 is not included in our interval. So when 0 is not included, it means that yes. Oh, no. It means that it is not equal. So the answer here is no. the um, mu1 and mu2 of the mu1 of the populations, okay, are not equal or unequal. Boleh faham? Sama juga untuk the first one. If you get both negative for the lower and upper boundary, same. No, it is not equal or it is unequal. It is only equal when we have negative for the lower boundary and positive for the upper boundary. This one, kalau you dapat negative and positive, yes, equal. Any question? No?
Tak
No,
ada
no.
Semua
doktor.
faham?
Doktor.
Okay. Alright. Thank you. So, saya padam dulu ni kejap. Okay. Okay, now, let's go to the second one, second case. I've explained this before. Okay. So for the second case is both are unknown. Okay, dia tak ada case yang satu known, satu unknown. Biasanya dia akan bagi sama ada dua-dua known ataupun dua-dua unknown. Okay. But if let's say you terjumpa satu known, satu unknown, then still we consider it as unknown, just to be safe. Okay. And okay, now let's say that this is when both standard deviation of the populations of the two populations are unknown, but this time the standard deviations of the two populations are equal. Okay, equal. So bila equal, you need to use this formula. Okay, I think it is better for us to rewrite the formula so that you won't get confused. So the formula for this one is just use this one. Just use the expanded version lah. I call it as an expanded version of the formula. T alpha over 2 degree of freedom. Terus masuk the standard deviation of the difference, which is equal to pool standard deviation over 1. Okay. Takut nanti you confuse antara yang ni bila nak masuk kat mana semua kan. So, straight away use this one. Okay, so you tak confuse lagi dah. Okay, and for this one, you need to find again, you need to get the degree of freedom, you need to find the the pool standard deviation, and usually this one will be given in the question. The same goes to the sample size of the two population will be given. So, yang you nak kena cari biasanya pool standard deviation je lah. Okay, now let's look at the example 15. Okay. A consumer agency wanted to estimate the difference in the mean amounts of caffeine in two different brands of coffee. Okay, by the way, I would like to remind you all that in the test or in the final exam, the question will not be partitioned or apa diletakkan di bawah subtopik. Kalau macam ni easy kan. We know that example 15 is for case number 2, example 14 is for case number 1. But in the final or in the test, letter, you have to um, identify whether it is a one population mean or it is a two population means. Okay, and uh, you juga can identify whether the standard deviations of the population is known or unknown. Okay, semua tu you kena identify sendiri. Okay, now two brands of coffee. So from here, two brands. So you should have in mind that, okay, this is the case for two populations. Okay, but be careful. Sometimes the question give a scenario for two populations, but then later the question asks you to find the mean of one of the populations. Salah satu population. Dia boleh juga buat macam tu. You kena baca betul-betul soalan dia. Okay. And next is the agency took a sample of 15 1-pound jars of brand one coffee and the mean and that showed the mean amount of caffeine in this just to be 80 milligram. Okay, now again, so we have brand one and brand number two. Brand one and brand number two. For brand one, the sample size is equal to 15. And the mean for brand number one is equal to 80 milligram. With a standard deviation, again, with a standard deviation. So, disambung ayat tu kan? Again, disambung ayat tu. It means that the standard deviation here is the standard deviation for the of the sample. It is not the standard deviation of the population. So, the standard deviation of the sample is given by S, 5 milligram. How about brand number 2? What is the sample size? Number 2,
Sample size 77.
12.
12.
12.
Yes.
Yes. And mean,
Mean 77.
right? And the standard
Sample
deviation,
6.
6 milligram. Okay. Construct a 98% confidence interval for the difference. Okay, so now memang confirm soalan ni dia minta 98% confidence interval for the difference between the mean amounts of caffeine in 1 pound just of these two brands of coffee. Okay, kat sini yang boleh jadi tricky kadang-kadang. Kadang-kadang the question can ask you construct a 98% confidence interval for the mean of for the mean caffeine mean caffeine in for brand number one only. Kat situlah yang tu you kena guna yang one population, bukan two populations. Okay, and the last one, this is very important. Assume that the two populations are normally distributed and that the standard deviation of the two populations are equal. Standard deviations of the two populations are equal. Okay, for this one, this is the hint for you to choose whether you want to use case number 2 or case number 3. Case number 2 or case number 3. Let's say in the final exam, there is no last sentence. Dia tak bagi tahu ke awak whether the two populations are equal or unequal. So in that case, it is better for you to just keep it to yourself. You dah identify, whenever you identify that there's a problem with the question, you just keep it to yourself. Don't ask the EVG later, because Kalau biasanya, this is tips lah. Kalau soalan salah, you akan dapat markah free. But jangan terlalu overconfident. Buat je. Jawab je soalan tu. Okay? In case you yang tak faham. Macam tu. So you jawab je. But kalau soalan salah, just keep it to yourself. Kalau cakap kat invigilator nanti we will update you with the new questions, and then you have to solve apa the new question tu lah yang diberikan. Okay, so this one from the last sentence here kita tahu kita kena guna case number 2 because the two population standard deviations are equal. So case number 2, confidence interval of the difference. Okay. Okay, awak cari dulu ni 98% confidence interval means that alpha is 1 minus 0.98. This is equal to 0.02. Alpha over 2 is 0.01. Then find the degree of freedom. Okay, degree of freedom is N1 plus N2 minus 2. Okay, sebab kita, we are dealing with two populations. N1 is 15 plus 12 minus 2. 15, 12 minus 2. This is equal to 25. So the T critical value 0.0125. Refer to table number. Table number 4, right? 4 or 7?
7.
4, 7. Okay.
7.
Go to table number 7. Find the value for T 0.01 and degree of freedom is equal to 25. What is the value?
Two 2.485.
2.485. I just want to check, ada tak siapa-siapa yang dalam group ni yang maybe confused lagi macam mana nak baca? Table 7 boleh bagi tahu supaya saya boleh tunjuk.
Ada, doktor.
Ada. Okey. Kejap saya buka kejap. Oops, salah tekan. Sekejap ya. Table, statistical table. Okay. Now I will share with you the statistical table. Okay. Okay, right. So this is, can you see my table? Table number 7. Nampak?
Nampak, doktor? Betul.
Okay, alright. So yang kat sini alpha ni kan. Alpha ni ada 0.10, 0.05, 0.025 sampailah 0.0005. Kes kita sekarang kita punya alpha 0.01. Okay. 0.01 kat sini. So awak carilah pula degree of freedom. Degree of freedom 25 yang macam kita dah kira tadi. Sebab itulah you dapat 2.485 untuk T. Boleh?
Boleh, doktor.
Okey, ni tak boleh nak highlight. 2.485. Alright. So stop sharing. I will now share the window. Entire screen lah senang. Okey, boleh. Nampak screen saya? Oh, mana dia?
Nampak doktor.
Wait, where? Mana OneNote saya? Kejap. Teams? No. Hilang. Kat sini ke? Kejap. OneNote hilang. Kejap. Okay. Alright. Saya terpangkah ke tadi? Okay. Alright. So, confidence interval telah dapat ini tadi 2.485 and now we can calculate the confidence interval. So X bar 1 is 80 minus X bar 2 is 77 plus minus T alpha over 2. Okay. T alpha over 2 is 2.485. Oh, satu lagi lah. Sorry. Before that, you have to find, because this is case number 2, you have to find the pool standard deviation first. Okay. So the pool standard deviation is equal to N1 minus 1 variance of population sample number 1 and 2 minus 1 variance of sample number 2 and 1 plus N2 minus 2. This is equal to N1 15 minus 1 variance is 5 square. Okay, sebab ni standard deviation, so you have to square the value, and sample size for number 2, group number 2 is 12 minus 1. Variance of group number 2 is 6 square. Okay, over 15 plus 12 minus 2. What is the pool standard deviation? Please calculate the pool standard deviation here.
5.4626.
Yeah, 2.4626. Okay.
5 doktor.
Sorry?
5.4626. Bukan 2, 5.
Oh, 5. 5.4626. Okay. So now you dah ada pool standard deviation, you dah ada critical value, you dah ada all the informations required. Only then you can calculate the confidence interval. Okay, so this one is 80 minus 77 plus minus T critical value 2.485 times 5.4626 1 over N1 15 plus 1 over N2 12. Solve the equation.
Minus 2.2575 mg.
2.2575 mg. And the upper boundary?
8.2575 mg.
8.2575 mg. Semua dapat? Semua dapat negative 2.2575 and 8.2575. Okey ke tak?
Dapat doktor.
Tak, tak ke okey?
Dapat.
Dapat. Okey. Alright. So, okey cumanya kan, saya ni kan buat kat sini, lepas tu kat sini, cuma awak buat cantik-cantik lah ya. Buat ikut susunan dia yang betul. Yang ni dulu, paling kiri, yang ni tengah, and then barulah yang ketiga. Alright. So, I hope semua okey, semua boleh ikut. Online ni kita tak nampak. So, boleh saya tahu kalau kod-kod ada yang tak okey, boleh bagi tahu kat mana yang tak okey. Kalau tak okey, kalau okey kita sambung. Sikit je lagi nak sambung. Semua okey? Alright. Kalau semua okey, the last one for today is example 16. Okay. So example 16 here is this example gives us the Minitab output. Okay. And kalau awak tengokkan dekat Minitab output ni, first of all, there is no assumed standard deviation of the population kat atas ni. Kalau ingat yang one population mean, dia ada assumed standard deviation for the population. So because there is no assumed standard deviation of the population, so we need to use the standard deviation of the sample here, right? So you kena tahulah bila kita guna standard deviation of the sample, means that we need to use case number 2 or case number 3. Case 2 or case 3 only for two populations. Okay, then bawah sekali ialah both use pool standard deviation. This is the SP that we calculated earlier. Okay, cuma this is from another example lah. Of course, the pool standard deviation value is different. So for this one, this is the SP. So when bila baca output, then you notice there's an pool standard deviation given, you should know that you need to use this case number 2. Okay, the formula yang ada SP kat dalam dia. If this is not given, if the pool standard deviation here is not given, then use case number 3 to calculate the confidence interval. Okay, and now let's look at the example. Verify that the pool standard deviation of the data is 9.0587. So you can use the SP formula to calculate the value and prove that it is equal to 9.0587. Ini contoh soalan yang baik tau. Kalau soalan tu dia kurang baik sikit, dia akan letak A ke contohnya kat sini, and then the question will ask you the question will be find A. So you tak tahu nanti whether your answer is correct or wrong, because soalan minta find A sahaja. Okay, kalau soalan tu baik, dia bagi macam ni lah, proof. So kalau you tak dapat the answer is equal to 9.0587, then there maybe something wrong with your calculation. So please do it again until you get the answer. Okay. And the other one is sometimes to get or to use the formula. So again, this is the formula, right? For case number 2. Okay, this is the formula. And katalah soalan tu dia tak bagi standard deviation, yang mana you kena cari standard deviation, but at the same time soalan tak bagi standard deviation. So what you need to do to find the SP, because without this you cannot find the confidence interval. Standard deviation is not given. Macam mana nak dapatkan standard deviation ni? Anyone? Anyone? How to get the standard deviation? By using the standard error mean and also the sample size. Kita tahu kan yang that the standard error for the mean is equal to standard deviation over square root of n. So, oops, sekejap Untuk case yang ni, standard deviation lah. Kita buat macam ni lah. Macam tu kan. Kalau untuk sekejap, of the sample mean. You kena ingat balik this formula lah. This basically standard deviation of the population over square root of n. But now kita tak ada standard deviation of the population. You can just replace with the standard deviation of the sample. Okay, so to get the standard deviation of the sample here, okay, sekejap saya buat standard deviation of the sample. You tak tahu. So to get the standard deviation of the sample, it is actually the standard error mean times square root of n. So yang ni you akan dapat 2.3 darab square root of 13. So you should get the answer 8.31 untuk sample number 1. 8.31 untuk sampel number 1 and untuk sampel number 2 you akan dapat the same lah. Standard error mean untuk yang kedua 3.2 times square root of 10. You should get the value is equal to 9.97, right? Sama tak?
Dia ada plus minus betul.
Dia
Dia
ada
macam
plus.
kalau yang S1 tu saya dapat 8.30.
Okey. Sikit-sikit lah kan. Sebab yang ni dia dah bundakan kot. So you boleh gunalah nilai yang you dapat 8.30 berapa? Yang 30?
Dia 8.2928.
Oh, 2928. Okey. So you guna je lah 2928 sebab dia kat sini, sebab yang standard error mean ni dia bagi 1 decimal places je kan. Sebab tu kita dapat macam tu tadi. So yang satu lagi 9 point. 9.9
Yang tu
Hello?
dapat
Ha.
10.1193.
Oh, okey 10 point 10
Betul tak tu?
193 jauh juga. Macam tu lah. Dia sebab decimal places. Sebenarnya decimal places. Okay, so bila dah ada yang ini barulah awak boleh calculate the full standard deviation. Bila dah ada full standard deviation, barulah boleh guna formula ini untuk calculate the confidence interval. Okay.
Boleh doktor.
Boleh ya? Okay. So, ada apa-apa soalan? Saya tak nak discuss lah dulu yang number 3 ni sebab dia ada groups sampai sini je tadi. Okay. Takut nanti tak sama pula. No question?
Tak ada doktor.
Tak ada. Alright. Uh, saya was-was pula. Okay. Betul tak ada question? So, yang lain?
Tak ada doktor.
Ada.
Okay, alright. So, kalau tak ada soalan, I think that's all for today. Thank you very much and see you again next week. Okay, so kalau for students yang kelas